Hello everyone. In today's video, we are going to discuss one more number program over here, the prime number. As we know, the prime number is a very common number which can be asked and which we are studying in our previous classes. What is exactly a prime number? You must know the example. 2 is a prime number, 3, 5, 7. But how are you going to define it? Whether these are the prime or not prime, and not prime can be as we treated as composite number. So always remember a number which having maximum 2 factor including 1 and the number itself is said to be a prime number. 2 factor is the major condition. How many factors it have? 2 factor only. That is the important term over here. As we know, every number is divisible by 1. So there is no issue, and every number is divisible by own. So if any number which can be divisible by 1 and by own only, then only it can be treated as prime number. Or the other hand, if the number is divisible by more than that, then it is called composite number and not a prime number. So how are you going to be framing out this concept into the programming? So now let's take example is like, I suppose I have been taken 7 as a number. So I generally told you how to get the factors of a number. As you know, you must from a range from where to where the factors can be lie. So as you know, 7 is coming in 1's table. Yes or no? That means 7 modulus 1. Whenever we do the modulus operation, if it is completely divisible, so it always give you remainder 0. So we can say that the 1 is a factor of 7. Now moving on to the other, 7 modulus 2. Whenever you divide the 7 by 2, what remainder value you will get? You will get 1 as a remainder value. So you know that this 2 is not giving you 0. That's why it is not the factor of 7. Moving on. Next number 3. 3 cannot also give the remainder 0. It will return a 1. That's why it is also not a factor of 7. Moving further. That is 4. In 4, as you can see, 4, 1, 4, 4, 2, 8, which is that time you will get 3 as a remainder over here because it divide only one time. So it is also not a factor of 7. Then 5. If we talk about 5, 5 will return 2. Then it will also not a factor of 7, followed by the 6. The remainder is 1. So it is also not a factor of 7. But when you divide 7 by 7, it will give you a remainder 0. That is will be completely come. So you can see only in 2 places where 1 and 7 are there, then it can be completely divisible. So that means only 2 numbers are the factor of it. On the other hand, if I take the example of one more number, the common number which I am taking over here, 6. Suppose, so 6 modulus 1, remainder is 0. Yes, so it is a factor. 6 modulus 2, remainder 0. Yes, because 6 also coming in 2's table. Similarly, 6 modulus 3 also give you a remainder 0. So it is also one of the factor of 6. Now 6 modulus 4. No, this time 4 will not return you 0 because 4 will return what? It will return 2. So it is not the factor. Don't worry, move further. We'll perform the operation over the 5. So as you can see, 5 also not return the remainder 0. It will return 1. So it is also not a factor. And 6 modulus 6. Yes, 6 is always coming in the 6 table. That's why it's written remainder 0. So now as you can see, we have been finding out the factors of a number. So here you can see how many factors? 1, 2, 3, 4. So now, and here you can see how many factors? It's 1 and 2. So what was the condition of the prime number? That a number must have maximum 2 factors, including 1 and the number itself. So that's why it is called a prime number, and it is not a prime number. Now few things has been drawn from here. What exactly we are doing and what is the purpose behind it. Now here you can see the concept, the very first concept you can drawn from here is the running of the loop, because we need to be repeating this task time and again, modulus, 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 every time we performing a modulus. So till where, from where to we have to being start, we have to start till 1, and maximum here we was taking the number is 7, so maximum it will goes 7, and here we have taken a number 6, so maximum it will goes till 6. But what about the particular number? If suppose we have been taken a number n, the maximum range will be what? It will be I started from 1 up to that number, alright. And what is the updation? Because whenever we take a loop, it must be have a updating statement. So what are the updating statement? So we can be worked over here. 1 can be 2, 2 then 3, then 4, then 5, then 6, then 7. So how many values are updating over here? 1 to 2, the jump is 1. 2 to 3, again the jump is 1. 3 to 4, the jump. So we are updating the value by 1 only. Is that clear? This is the condition of the program, and these are the basic concept, how we making a program, how we forming the concept of a program. Because every time you are not going to supposed to be learn and by heart the program. You need to be design the program. We never say that the similar program will come in your examination. We never say. Nobody can say that. But the real picture is that you must understand what concept we can use whenever these similar kind of program are coming in your examination. Alright. So few important things here, that firstly we have to decide that how many inputs we need to be required over here. What we taking from the user over here, that is the number. Alright. After that we need to run the loop which is started from 1 up to n. Then we need to find it out the factor. For finding out the factor, the condition is what? What exactly the condition was? I just let you know about the condition. Condition is, if suppose in place of 6 we have taken a number, then n modulus 1, 2, 3, 4, 5. This can be clubbed inside a loop variable. So that loop variable can be mentioned over here, and it has to be returned 0. And we can form our condition by the help of this example. So without any further delay, let's start the program. So before starting the program, I always suggest you must understand how many inputs are required. We required one input only, that is the number. Import java.util.asterisk semicolon. Why you using import over here? Because with the help of import, we can simply implement util package, followed by the class and the class name. As we finding out the prime number, so I'll take appropriate name as prime, followed by the curly braces, that is the scope of a class which is going to be closed at the end of the program. Now it's time to design a main method. Main method must consist access specifier, which is public over here, modifier, that is called static, then data type, that is void, and the method name, which is main over here. Inside that we pass the string array argument over here. So I'll write a string args and the argument brackets over here. It's time to open the scope of a method with the help of curly bracket. Now it's time to design the scanner class object. Why we using the scanner class object? Because whenever we require a value from the user, we always use scanner class objects. So how are we going to create it? Scanner, which is a class name, object, I am writing SC as an object name. New is the keyword which is used to allocate the memory for the instance variable. What variable we are using? Instant variable, and new scanner, which is again a class connecting the input devices over here with the help of system.in. Now close. It's time to give a message to the user. With the help of that, we'll use system.out.print. ln we have giving over here to changing the line. Whatever message you need to be mentioned, it has to be given inside the double quote. Opening, I am asking to enter a number, and it has to be closed at the end. Put the semicolon, that is a terminating statement. A number will be the integer type, that's why I am taking an integer data type, that is called int. I am taking small n to hold that number. For this we use the object which we have just made it, that is sc, which call a method. Which method we'll use? Which providing, that is next in. This method has been mentioned inside the scanner class, that's why the entire scanner class has been used. Now till here you have been already taken the inputs from the user. It's time to design the code. Before designing the code, I'll just let you know that how you come to know that how many factors a number is having. For that you need a one counter variable. So number of required variable can be mentioned over here. So I'm taking one variable, that is c. What is the purpose of c? C is a counter variable which tells what? It tells the number of counting, that how many times the number is completely divisible by the particular pass value. So it is also referred to be storing the number of factors. Alright, so we have been taken C over here. As you know, this value should not be exceed more than what? 2, because a prime number is a number which have maximum 2 factor. Initially I was taking only 0 over here. Now it's time to design the loop. So I'll start at the loop from for loop I am taking. As I told you the condition, the initialization of I will be started from 1 and maximum it will goes I less than equal n. If you don't want to run the loop till that value, so you need to be checked that this time you will get only one factor. Alright, this thing has to be clear. Now it's time to provide the condition which we have made over here, that we need to be checked. If number modulus by the variable is give you the remainder is 0. Alright, that is a factor finding condition. That means if the number is completely divisible by the value, that value is the factor of a number. So how you come to know that? So for once this condition is true, we simply update the counter value. Instead of writing C++, you can also write C equals C plus 1. There is no issue in that. Alright, then close it and close this bracket. Now at the end you need to be checked how many times and what will be the value of maximum value of this counter for the prime number. As I suggest you that it must be maximum 2. If the counter is holding maximum 2 value, then the given number system dot out dot print given number is prime number. Else, because if we have a if, then it must have else. System dot out dot print ln, or print and print ln, anything you can mention over here. Number is composite, or you can say it is not a prime number or composite number. Close it. It's time to close the bracket. How many brackets we have been open in the program, beginning of the program? Just quick look. The first bracket, then second bracket. Alright, I'm just putting this arrow, don't put it in that. I'm just reminding you. This 1, 2. Any other bracket? No. Here, this is for bracket which being already closed. The if bracket which is already being closed. Then how many brackets are still open? These 2 brackets will be ended over here. Now, this is the entire program of a prime number. I just quickly look that the dry run of this program can be shown over here. Now, in here we have been taken a number. Suppose I have been taken a number is 6. we are going to be check, or rather 6, I'll take any of the prime numbers, so I'm taking 5 over here. This 5 have been stored and one variable we have been taken. Number which we have been taken, that is 5, the other variable which we are having, that is C, which is a counter variable. Now the code is started from here, we are running the for loop. In the beginning, as we have a variable I, the initial value of I is 1. So 1, the maximum condition is less than equal to the number, so less than equal 5. So now it's time to check the condition. Once the condition is checked, then only you're supposed to allow inside the loop. So now condition is true, get inside, n modulus I. What is n? 5 modulus I, that is 1, is give you remainder 0. Here this is the condition. Yes, condition is true. So it's mean we are updating the value of C. So now the value of C, which was initially 0, now it being updated and it becomes 1. Clear? Now once again, once you have been reached, you reach over here, again you have to be run and update the value of I. So this I will become 2. 2 is less than 5, condition is true. This time 5 modulus 2 will give you remainder 0. Yes or no? No, this time 1. As you know, odd number, it is not completely divisible by 2, so it is not going to be update. Next, again we update the value of I. Now it's tend to be 3, 3 less than 5. Yes, condition is true. Now 5 modulus 3 will give you 0. No, it will not give you 0. This time it will give you 2. So again, the C is not going to be changed. Update this value of I. Now I value is turned to be 4, 4 less than 5, condition is true. 5 modulus 4 will give you the 0, no. This time again it will give you the 1, so once again it is not. Now update the value of I, which is 5 less than equal to 5, condition is true, yes. 5 modulus 5, it give you the remainder 0, yes, definitely, because 5 is coming in the 5 table. So now this time here C is 1, C is 1, it will remain same till here. But now here the C value will be changed, updated by 1, it becomes 2. At last, we'll again update the value. We can't quit the loop until the loop condition becomes false. So this time the I becomes 6, 6 less than equal to 5. Now here the condition is false. Once the condition is false, the loop is terminated and you have been reached over here, where we are checking the value of C. What exactly the C current value? That is 2, and 2 is not, 2 is equal to 2. Yes, condition is true. So that's mean the number which we have given as a user, I was taking 5. It doesn't mean every time you take 5. You can take any of the number 12, 13, 14. If in that situation it satisfies the code, then it is said to be a prime number. Otherwise, it is a composite number or a non-prime number. Alright. So at the last, we just simply quickly finish the program with the help of the VDT. VDT means, as you know, variable description table. So we design the variable first, followed by the data type and the description, or we can say the purpose. As you know, it is one of the important part that designing of VDT also contain a marks. It is, although it is not compulsory in class 9, but it should be in your habit so that you will not face any difficulty in class 10. So how many variables we have been used? We have been used the small n. Yes, the data type of that int. What is the purpose? To store a number. Any number which is given by the user. Only the short messages can be provided, followed by the C, that is also again the integer data type to hold the number of factors. Yes, any other variables, that is I. It is also int, which is, it's a loop variable. That value can be changed and be dependent on the loop. So you can simply mention the loop variable. I believe only 3 variables has been used in this program, and these are very simple. That is quite very easy. Although the comment writing is also an important part, but still we are doing the VDT designing. You can be, there is an option between comment writing and the VDT. So we generally prefer to writing VDT. You can choose the comment writing as well. I'll let you know in the few more videos. So till the time, we are going to wind up the session over here. I believe you will practice the program and you will not face any kind of difficulty. So for the today's session, thank you so much. We'll meet you in the next session.